recording here. Okay. So today we're just going to go through the practice test. Does everyone have a copy of the practice test, or do you need a copy? Yeah. Anyone else need a copy? Yes. Well, we'll see. I also have extra copies of that formula sheet just for when you're practicing. All right. Does anyone need a copy of the formula sheet before we get started? Okay. So these ones are yours to keep. And oh, here they come, huh? Yeah. You guys all have your practice tests and formula sheets? Yes. Extra? Okay. So there we go. That's what I thought. Formula sheet, anyone? Do you need formula sheet? Practice test? Okay. I will have to go grab photocopies. Stay close to someone so you can look at those, and then I'll grab you photocopies after class so we can get started. So, because I'm all out of copies now, so after class I'll run grab photocopies. But until then, yeah, it's on the middle. But until then, you can share, okay? Because we'll write the answers on a separate piece of paper, anyways. All right. We're only going to go through 1 through 5 together, and then I'll just post the solutions for the rest of the questions because they're just little quick ones, right? And so we're not going to go through those together. My throat's killing me, so, but also I usually don't anyways. So, all right, let's see here. So we're going to start this off with a linear programming question. All right, what's nice about this one is it tests, do you know what a straight line equation is? Do you know how to draw a straight line? Do you know how to find a feasible set? Can you maximize the profit function given these constraints, right? So it tests a lot of things that we covered. So let's go through here. And I'm just going to copy this. Oh, I guess. Oh, come on. So now we're doing the solutions. All right. I'm guessing you took a stab at these already, right? Hoping. So we've got some profit function, right? 2x plus 5y. And then we've got subject to these constraints, right? And so remember the steps that we do is we draw these constraints on the graph, and then we figure out our feasible set, find the points of intersection, evaluate the profit function at those points of intersection, And then we've maximized the profit function if we pick the largest one. Nothing to it, right, guys? All right. So step one is to draw the constraints on the graph. To draw these lines, right, these are straight line equations. I find it's easier if we move them into y equals mx plus b form. You don't have to, right? But at the end of the day, we have to find 2 points on each line in order to draw the line, right? We only need 2 points, then we connect them and draw the line. Okay? And so we need to find 2 points on each line in order to draw them. I personally find it easier if the line is in the form y equals mx plus b, but you don't have to do this step. But what I'm going to do is I'm just going to take each of these constraints and solve for y. Remember that we can use that inequality as an equal sign as long as we're not multiplying and dividing by a negative number, because then the sign switches. But that's not going to happen. So, all right. So let's call this first one equation 1, and then the second one equation 2, and we've actually got this third one equation 3. I don't care about x has to be greater than 0 and y has to be greater than 0. That's just forcing me to be on the grid that I gave you, right? So we can ignore these, right? So they're just on there for completeness, but we don't need them. Okay. Oh, is it locked? Okay, try again. Is it locked? Closed for business. Business math. All right. So equation 1, 2x plus y is less than or equal to 16. We want to draw the line of 2x plus y equals 16, right? That's the line. The inequality tells you the region that you want, so it's always going to be everything below it. Okay. So equation 1. If we're solving for y, we get y is 16 minus 2x. That was easy. Find 2 points on line 1. Do you remember how we did that? Typically, we can just set up kind of a table. We pick any value of x that we want to plug in there, and then we solve for the value of y, right? That tells us that those 2 points are on the line. And so, of course, an easy value of x is 0. So I always usually pick that. If x is 0, in this case, y is 16 minus 2x. So we get 16 minus 2 times 0, which is just going to be 16. If you wanted to be clever, oh, maybe a clever question. You can put any value of x, but I use 0. Yeah. So this is a point that's on this line. So here, in terms of x, y, right, when x is 0, y is 16 on this line. Okay. So if you wanted to be clever, right, and we do, what if we said, okay, well, what if y is 0, then what's x, right? Because sometimes that's what we have to solve for later anyways. So we may as well do that work, right? Where does it cross the x-axis, right? Sometimes it's not reasonable because it might not be on the grid that I gave you, right? That's possible, but often it will be. So how about if we force y to be 0, let y equal 0 is 16 minus 2x, and solve for x, we get 2x is 16, so x must be 8, right? 16 divided by 2. So then I know right? Like I said, you can pick any value of x, but now I know where it crosses the x-axis as well, right? I know where it crosses the y-axis, and I know where it crosses the x-axis, which might be useful. So now I saved myself a little bit of work, potentially later on. How about equation 2? Equation 2 was 2x plus 3y is 24. So equation 2 was 2x plus 3y is equal to 24. Solving for y again, I get 3y is 24 minus 2x. So I get y is 24 minus 2x all over 3. So let's see if I simplified that here. I did. So y is 24 over 3 minus 2x over 3. 24 over 3 we can simplify to 8, but 2x over 3 is just 2x over 3. Okay. So now again, we need to find 2 points on this line. So find 2 points. Again, we can pick any value of x and y. X equal to 0 is always easy. 8 minus 2 over 2x over 3. If x is 0, then y is 8. Sorry, I'll do that properly. 8 minus 2 over 3 times 0, which is 8. What if we were clever again and just solve for y equals 0 and solve for x, right? And so again, let y equals 0, which is 8 minus 2 over 3x, or 2x over 3, doesn't matter, and solve for x. We get 2x over 3 is 8. Moving that 3 over, we get 8 times 3. Y is 0. Add it up here. Which one? This one? This one? This one? Yeah. Mm.
Solving it would be 8 minus 0.
Yeah, 8 minus 0 is 8.
Yeah, I think that's what they're asking.
Oh, okay, thank you. Hey guys, was it this one?
Yes.
Yeah?
It's good.
It's okay?
Yeah.
Okay. All right, so multiply the 3 over, we get 2x is 8 times 3, which is 24. Yeah, phew. And then we can divide both sides by 2, so we get x is 12, right? So what that tells us is that up here in our table, right, when y is 0, x is 12. And I'll just highlight that here and here. Like I said, you can continue and just use whatever value of x that you want, right? Probably a good idea is to make sure that it's a value of x that you have in the graph that I've given you, right? Because the graph that I give you should give you an idea of what everything's going to look like, right? Or what scale it's on. Okay. So in terms of our points here, right, in terms of our xy points for line 2, we've got 0, 8, and 12, 0. Okay. That last equation that we have is just y has to be less than or equal to 6. That's just going to be a constant equation, right? At y equals 6, it's just going to be a straight line at 6. We don't need to solve anything, right? And so I'm not going to put any work in, because no matter what value of x you put in, y is just going to be 6, right? So that's why it stays constant. Okay. But what I will do now is I'm going to steal this grid here so that I can use it. Copy and paste. There. Okay. So I did color code these points, right? Line 1 had points at 0, 16, and 8, 0. So I'm going to put those on here. 0, 16 is up there. And then 8, 0 is down there. If I connect these points, remember you can just take any straight edge, connect the points, extend the line, right? And then you've drawn that line. So let's see if I can do it here. I sort of missed, but that's okay. All right. So here, I'm going to say that this is line 1, which we found had the equation y equals 16 minus 2x. Okay. Or if you prefer, 2x plus y has to be less than or equal to 16. So the less than or equal to, it's just saying that from this line, you want everything below it, right? But that's always going to be the case when we talk about the feasible set later. It's just going to be everything kind of below it. Okay. So let's draw that second line, which I had in green. We've got a point at 0, 8. 0, 8, and 12, 0. 12, 0. So again, I'm just going to take a straight edge, connect these lines, and see what I can do here. All right. Ah. Nice. This is equation 2, which we said had the equation y equals 8 minus 2x over 3, right? And then let's not forget about that last line, which was at y equals 6, right? So y equals 6, and I'll just see if I can, when x is 0, actually, I'm not even going to draw the point because we don't need to. Okay. I'll try to draw a straight line here, but might be a little wonky, but it's okay. This is the third line at y equals 6. Okay. Phew. That's step 1, done. But it's a lot of the work that's done too, right? Because now we want to find the feasible set. The feasible set is the area, so this area that satisfies all the equations at the same time, right? And so we said, okay, everything has to be below this line, and below this line, but also bigger than this line. So what's always going to happen for your feasible set is that it goes from here and it just stops whenever it hits a line. Okay. I don't know if they're trying to get in or if they're waiting or. Oh, come on in. They don't want in. Come on, feasible sets. Okay, so for your feasible set, you're just always going to start here, and then everything until you hit a line is in your feasible set, right? Nothing beyond it. So step 2, I'll say shade. Shade the feasible set. Which I will do in yellow, how about? Okay. So it's going to be all of this area here. And I'll just make a note here that this is the feasible set. Okay. That was an easy step, right? So then now the next step, remember, is to identify all the intersections of the feasible set, because as a fact, the profit function will be maximized at one of these points, right? And so we only care about those points. All the points, all the XY coordinates in the feasible set work, but the profit will be maximized at one of the outer points. Yeah.
So you make the line like y is equal to x. So the line which you are taking from the left hand side is x-axis or y?
Oh, so here, this is your x-axis and this is your y-axis. Yeah, no worries. Okay. So, step 3. Find and label all points of intersection. So what I'm going to do up here is in purple, and I usually start, and it doesn't matter where you start, but I usually start at the origin at 0, 0. That's an intersection. It's never going to maximize your profit function, right? Because it's 0 and 0 makes 0 profit, but it is an option. So we always have to consider it. Moving around clockwise, then I'm going to label these intersections B, C, D, and E. Notice what's nice here is we already did the work for finding this point. So if you hadn't done that already, you would have to do that now, right? So what I'm going to do is I list all my points of intersection, A, B, C, D, and E. And then I'm just going to talk about what they are, if I know them, or which lines I need to solve for, just to give myself a roadmap of what I need to solve for still, right? So A is 0, 0, we know that. B is 0, 6, we know that. C is the intersection of line 2 and line 3. Okay. We don't know what that point is, so we're going to have to solve for it. Right. It's fine because one of the lines is y equals 6, so it's going to be pretty easy, right? But we still have to solve for it. And so it's the intersection of line 2 and line 3. So I just make little notes to myself saying, okay, well, that's one that I have to solve for. How about D? D is the intersection of line 1 and line 2. So we also have to solve for that because we don't know what it is. Okay? You'll always have to use equations to solve these because we drew these lines and we can't just look and say, oh, there it is. Right? We have to use math. And so it's the intersection of line 1 and 2. The intersection of line 1 and line 2. And then E is the intersection of line 1 and y equals 0. We already solved for it, right? But in case you haven't, I'll write it down here. Intersection of line 1 and y equals 0, which we know because we already solved for it, was what, 8, 0? Yeah. But that's only because we solved for it in the beginning, right? Otherwise, you'd have to do a little bit of work trying to find that. There, the intersection. Okay. So now we have to find the missing intersections. Find the missing intersections. So the first one is C, which we said was the intersection between line 2, which was what? Y equals 8 minus 2 over 3x, or 2x over 3. Doesn't matter. Multiplying and dividing. And line 3, which is y equals 6. This is nice, right? Because we know if y has to equal 6 and y has to equal 8 minus 2x over 3, we can just set them equal to each other, right? Because they're both y's. And so we get 6 must be 8 minus 2x over 3. And if we slowly try to solve for x here, we're going to move the 8 over, so we get 6 minus 8. Negative 2 is negative 2x over 3. Can multiply by 3 to get negative 6 is negative 2x. So x must be 3.
Wait, so I can just use the line equation for that, right? To find that answer too?
Well, so that's what
Sorry.
you can confirm that it looks reasonable that x equals 3, which it does, right? But the answer might be something like 3.2, and we can't see that, right? So that's why you have to solve it mathematically to find it. So you can't use the graph to say, oh, it's at 3.
Not the graph. I just
No?
use like the actual 3x plus 3y.
Oh, yeah, totally. Yeah. Yeah, you can use either one. I'm just using the one that's solved for y already. Yeah, but they're the same. Yeah. So you should end up at the same answer. So therefore, C is at 3, 6. Intersection D is the intersection of line 1 and line 2. So same thing. D is the intersection of line 1, which was y equals, now I've forgotten here, 16 minus 2x. And line 2, which was y is 8 minus 2x over 3. Again, it's nice because these are both y equals, so we can just set them equal to each other, right? Because both have to equal y. And then we can solve for x, and then we can substitute that back in. So we're solving this system of equations by substitution. You definitely could use elimination if you wanted to, but I like substitution, especially when they're set up like this, right? But we are just solving systems of equations here. So we get 16 minus 2x has to equal 8 minus 2x over 3. So I'll move my x's to one side. I'll get 16 minus 8 is negative 2x over 3 plus 2x. Eight is negative 2x over 3. Do you remember how to add fractions? We have to get a common denominator, right? So plus 2x times 3 over 3. I can multiply by 3 over 3. 3 over 3 is just 1, right? So I'm allowed to do that. And then that'll force it to have the denominator of 3. So we get negative 2x over 3 plus 6x over 3. Because I think we can all agree that 6x over 3 is the same as 2x, right? So nothing's actually changed. But I'm able to add these up, so equals 8. So 8 is negative 2x plus 6x is 4x over 3. Right. We're doing all the things in this problem, right? Dealing with fractions, solving systems of equations, all the fun stuff, drawing lines. Now we can start solving for x, right? And so 8 times 3 is still 24, is 4x. So x must be 6. Therefore, D is the point 6. Oh, I don't know what y is, so I can't do that quite yet. Sorry. I forgot. I have to substitute it back in. But I know that x must be 6 at that point. which I can confirm by just looking at the graph, right? At point D, yeah, it looks like X is sort of 6, right? I drew this line, so it's not perfect, right? So we have to be kind of flexible, but it looks like 6 is approximately the X, right? So now we're gonna solve for the Y. Remember, we've got 2 equations to choose for from Y. I'm gonna use equation 1 because it's easier, right? But you could just as well use equation 2. They have to be the same, right? Because we force them to be the same at X equals 6. So 16 minus 2X, so now solve for Y. I will use equation 1, which says that Y is 16 minus 2X, I think. Yeah. So Y is 16 minus 2 times 6. So Y must be 16 minus 12. Y is 4. Now we can say, therefore, the intersection D is when X is 6 and Y is 4. All right. If you hadn't already solved for the x-intercept, you would have to do that here, right? Which is no problem. It's we have to set line 1 equal to 6, right? Y equals 6. Sorry, y equals 0. I don't know, I'm out to lunch. Y equals 0, right? Because that's where it crosses the x-axis. But we've already done that, so I'm not going to do that. Okay. We've got all our intersections. The next step is we make a table of all the points of intersection, and then we're going to evaluate the profit function at each of those points, right? To figure out which one is the largest profit. Okay. And so can't remember what step this is. Step 4? Sure. Step 4, make a table of all points of intersection and evaluate the profit function at each point to find the point that maximizes the profit function. So again, so I've got my intersection here. I'm going to list them. A was 0, 0. B was, instead of scrolling, I'll just steal it from here. 0, 6. C was 3, 6. D we just found is 6, 4. Right? Yeah. And E we found earlier was 8, 0. Okay. This is the first time that the profit function comes into play, right? So we've done all this work completely ignoring the profit function, right? So this is the first time that we bring it in and we say, okay, well, remember that the profit was P, which is 2x plus 5y. Okay. So now we've got XY combinations that we're going to try. And whichever one is the largest, of course, that's the one we want. Right? And so we just go through 2 and 0 plus 5 times 0 is a profit of 0. No surprise there. 2 times 0 plus 5 times 6 is 0 plus 5 times 6, which is 30. Two times 3 plus 5 times 6 is 36. 2 times 6 plus 5 times 4 is 32. Close, but no cigar. 2 times 8 plus 5 times 0 is 16. If I gave you a list of these possible profits, which one do you want? Probably 36. All right. So that's the maximized profit. Maximized profit. So we're going to write the therefore, the profit is maximized to 36 when X is 3 and Y is 6. That's a big question, right? And how about this? I promise it's not on the final exam. Just on test 1, you just have to get through it one time, and then it'll all be over. Okay?
It's just going to be.
And should it be this question? Yeah, but that's because I'm yapping. All right. So you feel like you got a good handle on it. I know it's a lot of steps, right? But just work through it, right? There is a procedure that you're going to work through, and it's not going to be that bad. Hey, here's another maximizing function, but way different, right? Sure is. So question 2, we're going to maximize this function, right? If I just give you a function like this, what are the steps to maximizing it? To maximize it, the first thing we have to do is find the derivative, right, which we did last day. Talked about finding the derivative just of a polynomial, right? Nothing crazy. We set that the derivative equal to 0. Solve for the x that makes that happen, because that's going to be the x where the profit is maximized or the function is maximized. Right? And then we can evaluate what the function is at that maximized point. So again, there's going to be unofficial steps, right, that you can follow. So step 1 is to find the derivative of f of x. Remember, we denote the derivative by a prime. F prime of x is, so if f of x is negative 125x squared plus 300x minus 2, remember what we did? We just kind of gave it a bump from the right, and all those powers fell down in front and multiplied the coefficients, and then we decreased the powers by 1. Right? So in this case, we get negative 125 times 2, x to the 2 minus 1, plus 300 times 1, right? X is technically x to the power of 1, times x to the power of 1 minus 1, minus 0, remembering that the derivative of a constant is 0. So if there is no x, it just goes to 0. So so the derivative just kind of shrinks everything down 1 degree. Right? So from here, we get negative, oh, yeah. Which one? These ones? It's because we're taking the derivative, right? And so imagine, right? Because what we said was, okay, to take the derivative, we give this a bump, right? And then this power falls down in front, so that's why that's here. But then this power decreases by 1, right? Same thing here, x is actually x to the power of 1. 1 falls down in front, and then we're left with x to the power of 1 minus 1. Right? Okay. And then the constant has no x, so it goes away. Okay. So we've got negative 125 times 2 is negative 250 times x plus 300, because x to the power of 0 is just 1, right? And we talked about those facts last day, that x to the power of 0 is 1, or anything to the power of 0, actually. So now we have our derivative. Okay. Step 2, set the derivative equal to 0 and solve for x. Set the derivative equal to 0, bless you, and then solve for x. So what we have is we have f prime of x. We're going to force it to be 0, but f prime of x is also equal to negative 250x plus 300. Right. I can solve for x. If I want to move the 250 over, 250x is 300. Then I get x is 300 over 250. 300 over 250, we get x is 1.2. So now we know that when x is 1.2, that function will be maximized, but we want to maximize the function, so we have to use x equals 1.2 in the original f of x. So step 3, evaluate f of x at the x found in step 2. So just keeping track, because you want to go back into the original equation, right? So f of x was negative 125x squared plus 300x minus 2. So we want to find f of 1.2, which just means substitute in wherever you see an x, use 1.2. So we get negative 125 times 1.2 squared plus 300 times 1.2 minus 2. Let's do 1.2 squared is 1.44. So I get negative 125. I'll show a little bit more work than you would have to if you just found that one term, that's fine. Plus, and then 300 times 1.2 is 360 minus 2. Now I'm going to go back in and find 125 times 1.44 negative, which is negative 180 plus 360 minus 2. So negate that, plus 360 minus 2. Oh yeah, 178. So therefore, the function is maximized to x equals 1.2. Okay. It's from that one. Good. Any other questions though? Yeah. Oh, it's okay. Yeah. So if you're looking at the practice test, I'm not out to get you guys. It'll be very similar, right? So it'll start with a linear programming question. Then I'll get you to maximize using a derivative. And then we're going to build a profit function and find the shutdown point and that CVP analysis. Then we're going to talk monopoly. So it'll be the same types of questions. Right? Yeah, this is not on the final either. Only test 1. It's not until question 3 and then 6, 7, 8, 9, 10, 11. Those are all final exam as well. Right? But the others, one shot. Okay. Let's see here. 3, potentially 5, 6, 7, 8, 9, 10, 11. You'll see similar types on the final exam, but not the rest. Okay. Yeah. Yeah. Mm-hmm. Too short or too long? Or just right? It doesn't. Usually people finish after around an hour. The longest I think I had people stay was an hour and 40 minutes. You get the entire hour and 50 minutes, right? So it should be a good, like, nice length, right? So you don't have to worry about time. Okay. All right, let's do question 3. Okay. Hey, Chatty Cathy's back there. All right, so let's do question 3. Ruth's milk carton opener costs $2 in materials, and each one takes 20 minutes to make at $30 per hour. So she charges $30 per hour, right? So essentially, it's costing her time to make each unit. Ruth's advertising costs are $30 per month, and rent for her place is $3,000. Yikes. From here, right, we're able to figure out, okay, what are her fixed costs and what are her variable costs, right? And then we can develop a profit function for this milk carton opener. So part A just says, find Ruth's profit function. The first thing I'm gonna do though, is I'm just gonna go through and outline, I'll just put them into these costs into categories, right? Fixed costs, variable costs, because what I'm gonna have to do, because there's two fixed costs, right? Advertising costs and the rent. So I'm gonna need to combine those into one fixed cost. Same thing for the variable cost. Okay, so my fixed cost, or maybe I'll start with the variable costs, because that's the order that they come in, right? So the variable cost is $2 in materials and 20 minutes at $30 per hour. Okay. How are you guys with unit conversions? 20 minutes is a third of an hour, right? And then a third of an hour times $30 per hour, right? Each of them costs $10 in time, right? And so 20 minutes, here I'll just do a little side thing here. 20 minutes is 20 over 60 hours. 20 over 60 is 1 over 3 hours. So 1 over 3 hours times $30 per hour we get 30 divided by 3 is $10 per unit. Because remember, your variable costs is the cost to make each unit. Okay. So our variable costs are going to be the $2 in materials plus the $10 in time. Right? And so the variable cost is 2 plus 10 times however many units. Right? So the variable cost is 12x. If I go back up here, the fixed cost is much easier to find, right? Because it's going to be $30 per month in advertising and $3,000 for rent. So the fixed cost is just going to be 30 plus 3,000. So the fixed cost is 30. Well, there's a lot of ways that you could go about building the profit function, but let's do part A, find Ruth's profit function. So let's get started here, right? You could have developed this inside the profit function, but I think it's nice to just have those two figured out, and then you can plug them into your profit function. Right? And so we know from our formula sheet that profit of X is the total revenue minus the total cost. The total revenue we can replace. Remember how we went all around the formula sheet? So we started down here at the profit of X, and then we moved around filling it in, right? And so the total revenue we can replace with P times X, where P is the price that she's able to sell each milk carton opener. minus the total cost, which is your variable cost plus your fixed costs. Remembering to keep the negative on the outside there, unless you've already brought it in, right? But you have to be careful that you don't lose that negative on the fixed costs, okay? Otherwise, it's like someone gives you money on top of your rent and all that fun stuff, right? So that doesn't really make sense. So we can keep going here, px minus, and then we just said, we decided that the variable cost was 12x plus the fixed cost, which was 30. From the variable costs, right, if you're looking at your formula sheet, your capital C is 12, right? Because that's the cost to produce each unit. So now we'll expand this, p times x minus 12x minus 30. I can collect like terms and have x times p minus 12 minus 30. And that is her profit function. That's a lot of work, right? But once we have the profit function, then it's pretty easy to find things like the break-even point, the shutdown point, how much profit will she make if she sells 14 units, that type of thing, right? And so that's part A. Part B asks, what is Ruth's shutdown point? This one is kind of a little too simple, right? The shutdown point for any profit function is when P minus C is less than 0, right? Or when P is less than C. Therefore, Ruth's shutdown point is when P is less than 12. Right? And you can remember that by saying, okay, well, if I have P less than 12, right, then I have, let's say, 10 minus 12, that's -2. My profit would be however many I sold times -2. That's actually eating away at my profit, right? I'm paying $2 per unit I sell. And then minus our fixed costs, that's not good, right? So that's why we have to shut it down when this is less than this, right? Any questions about that one? No? All right. Part C asks what? If she sells the milk carton openers for $20 each, what's that telling us? It tells us that we have to set P equals to 20 now. What is her break-even output? Okay. So we're gonna let P be $20. Okay. Find the break-even output. Oh, clean that up. Find the break-even output. What's that asking? The break-even is when the profit is 0 and we solve for X, right? And so set profit of X equal to 0 and solve for X, right? That X is the break-even output. All right, so let's just start with our profit function that we developed. Our profit function was X times P minus 12. minus 30, 30. I'm going to force this to be 0, and also P is going to be 20 now, right? But that could change from question to question, right? So you want to remember what your old profit function was. So we've got x times 20 minus 12 minus 30, 30. Okay. I can move the 30, 30 over to the left-hand side, so I get 30, 30 is 20 minus 12, which is 8 times x. Yep.
So profit is equal to 0. Profit at x is equal to 0 or profit?
When the profit is 0, right? Because that's the break-even point. So you have a negative profit, and then you hit break-even, where it goes from negative to positive. And so that's why we force the profit to be 0. And then we have to find the x that makes that happen, right? Which is essentially asking how many things do you need to sell before you actually make a profit, right? So that's what we're doing. So we get 8x is 30, 30. So x must be 30, 30 divided by 8. Let's see here. 30, 30 divided by 8. I get an x of 378.75. One thing to note is that she cannot sell 0.75 of a milk carton opener, right? So we're talking whole units, right? And if she only sold 378, that's not quite enough, right? You would still have a slightly negative profit, close to 0, but still negative, right? And so what we do is we always round to a whole number, right? So the nearest whole number, 379. Okay. She can't sell 0.75 of a unit, so we must say x equals 379, right? And then I'll put in brackets here as x equal to 378 would still mean a negative profit. Therefore, she must sell 379 units to break even. It's a lot of milk carton openers. Seems kind of useless, but maybe. Any questions about that one? Okay. Then part D is similar, right? So now if she wants to make a real profit, so now she wants to make $5,000 in profit, how many carton openers will she need to sell if she sells them at $20 each still, right? And so we know the profit function, if P is 20, we can just skip to the profit of X, or actually, no, that's lazy of me. Part D, here we go. Let profit of X equal 5,000, solve for X. We use that same I've got a page break here, so I'm gonna write the profit of X is X times P minus 12 minus 30, 30 force that profit to be 5,000, right? This is the exact same as the question we just did, but now we're looking at an actual profit. And so 20 minus 12 minus 30, 30. So now as I move my 30, 30 over to the left, the left-hand side, I get 8,030 is 8x. So x must be 8,030 divided by 8. 8,030 divided by 8 is 1,003.75 units. Right? So again, we do the same thing, right, where we have to round up. Even if it was 1,003.1, right, 1,003 wouldn't quite put you at a profit of 5,000, right? And so you'd have to go to 1,004 to make at least $5,000 in profit. Therefore, she must sell 1,004 units to make at least $5,000 in profit. Any questions about that one? Oh, okay. There's going to be a bonus question, which is going to be attached to this question. I'm not going to tell you what it is, but it's a bonus. So there, you could potentially get more than 100% on this exam, and that's fun, right? It's a little bit tricky, but you can handle it. Okay, so that's something to look forward to. No, no, if you get the bonus wrong, nothing happens. Yeah, I'm like, ow. No, but I encourage you to try it. It feels like we did a lot of this last day, but that's because I moved section 3.1 to be with 3.4. Otherwise, it would have been all spread out, but it's okay. It feels like, hey, this is all new. Let me see here. Lips are so dry. Same idea, right? We've got this a monopoly, right, where we've got the total revenue and the total cost. If we know the total revenue and the total cost, we can build a profit function and we can maximize that profit function, right? So let's see here. So we're given, I'll just write them out here, that the total revenue is 37x minus 3x squared, and the total cost is 25x plus 9. Part A, what is the monopolist's profit maximizing level of output? That means we first have to find the profit function and then maximize it. So find the profit function. Then maximize it. Because it's going to be a quadratic, right? It's going to be a polynomial. So what we'll do is we'll take the derivative of it again, right? Find the derivative, right? And then it keeps going, right? So our profit function is always going to be, so the profit of X is the total revenue minus the total cost. In this case, it gives us what the total revenue is and what the total cost is. You're going to want to treat these as separate things, so I'm going to wrap them up in brackets and make sure that I expand properly, right, so I don't miss a negative. And so my total revenue is going to be 37x minus 3x squared minus the total cost, which is 25x plus 9. And it's that total cost one that can give me a lot of trouble if I don't bring in that negative properly, right? So I get 37x minus 3x squared minus 25x minus 9. If I collect like terms, and I'm actually going to move, so I have my highest power first and then decreasing powers of x. So I'm going to write negative 3x squared, 37 minus 25 makes plus 12x, and then minus 9. Make sure, yeah, good. Oh, I guess I can break these into steps if you want. So step 1, find the profit function. Step 2, and I'll skip this page break here. Step 2, for part A, find the profit function. Oh, sorry, part A, what's the monopolist profit maximizing level of output? So that's basically asking what is X at the maximized value, right? So it's asking solve for X and then solve for the maximized profit, right? So I've just broken it up into 2 parts. So step 2, find the derivative so we've got the profit of X, just so we have the original one up here, is negative 3x squared plus 12x minus 9. So profit prime of X, right, the derivative of the profit function is negative 3 times 2x to the 2 minus 1. You don't have to do that one. If you just write x, that's fine. Plus 12 times 1 times x to the 1 minus 1 minus 0. I get negative 6x plus 12. I guess I started writing these steps in a different color, so I'll try to keep that going. Step 3, let the derivative of the profit function equal 0 and solve for x. So we said that the derivative of the profit function is 0, which I'm forcing, negative 6x plus 12. Solving for x now is not a big deal, right? I'm going to move the negative 6x over to the left-hand side because it makes my life easier. So I get 6x is 12, so x must be 12 over 6, which is 2. That answers part A, right? This is the same as question 2 that we did, right? Essentially, we just had to build that function, and then we take the derivative, set it equal to 0, solve for x, and then we're going to plug in that x into our profit function, right? And so part A asked, what is the monopolist profit maximizing level of output? So we can answer, therefore, the profit maximizing level of output is x equal to 2. So now part B asked us what's the maximized profit. Now we have to just remember that we have to go into the original profit function, right? Not the derivative, the original profit function. And so maximized profit is at the profit at 2. Let's just remember what the original profit function was. Negative 3x squared plus 12x minus 9. Negative 3x squared plus 12x minus 9. So then the profit at x equals 2 is negative 3 times 2 squared plus 12 times 2 minus 9. I get negative 3 times 4 plus 24 minus 9. I get negative 12 plus 24 minus 9, may as well, negative 12 plus 24 minus 9, I get 3. So therefore, the maximized profit is 3. We don't have units, so I'm not going to throw a unit on there, right? That could be in thousands, it could be in millions, right? We don't know. Any questions about that one? No? After doing question 2, this one is kind of fine, right? So it's kind of 2 of the same type of question, which is nice. All right, which question are we on here? Oh, 5, right? Five is actually easy enough, except a lot of people forget that you have to solve for the quantity and price. So you want to solve for both Q and P, but this is just solving a system of equations, just like we were doing when we were finding the points of intersection, right? But in fact, this one's even easier because they're just Q equals this, Q equals this, Q equals this, Q equals this, right? So we've got these equations for our supply and our demand curve, and we're finding the equilibrium price and quantity. Okay. So part A, we've got, so S is a supply curve, D is a demand curve, but they're not adding anything to the equation, right? And so we've got Q is 16P, and then we've got for the demand curve, we've got Q is 12 minus 2P. We have to solve this system of equations, but we've got them both in terms of Q, so we can just set them equal to each other, right? 16P equals Q, but Q also equals 12 minus 2P, right? So I am using substitution here. You could use elimination if you wanted to, but I think substitution's probably the easier bet here. Right. So I've got 16p is 12 minus 2p. Trying to solve for p here, I'm going to move the 2p over to the left-hand side, so I get 16p plus 2p is 18p, which is 12. So solving for p, I get 12 over 18. 12 over 18, p is roughly 0.667. It's 0.66 repeating, but because we have an easier time dealing with decimals than we do fractions, I'm just going to use the decimal version. Right? But I can't remember if I changed it or if I asked for, bless you, just to leave it as a fraction, right? I might have asked you to leave it as a fraction, and if so, then 12 over 8, that's fine. You don't have to reduce it. Okay. So, all right, if p is 12 over 18, right, I'll put the p as 0.667 in brackets. Just to make it a little bit harder, I'll use p is 12 over 18, right, just to show off a little bit. And you can too. Because I'm pretty sure, now that I'm thinking about it, I'm pretty sure I asked you to leave it as a fraction, which means we have to use a fraction when we're solving for q. But it's not that bad, right? Because we can use either of these equations. Q is 16p or q is 12 minus 2p. We would get the same answer because we force them to be equal and then we solve for p, right? And so solve for q, of course, I'm going to use the first equation because it's easier. Q is 16p. Solve for q when p equals 12 over 18. So q is 16 times 12 over 18. 16 times 12 is 192 divided by 18. 192 over 18, which is roughly 10.667, but I'll put that in brackets. So for this first, so for part A, the equilibrium quantity is going to be 192 over 18. Oh. Therefore, the equilibrium is when Q is 192 over 18 and P is 12 over 18. Clean up my end here. How about part B? Part B, if we write out our equations, we have Q is 16p minus 8 and Q is 16 minus 2p. So we've got Q is 16p minus 8 and Q is 16 minus 2p. Again, I'm just going to set these equal to each other because they're both equal to Q. And so I can solve 16p minus 8 is 16 minus 2p. Bringing the p to the left-hand side, I get 16p plus 2p is 16 plus 8. So I get 18p, and 16 plus 8 is 24. So P is 24 over 18, I don't think there's a good answer, so I'll just leave it as the fraction now. Now solve for Q when P is 24 over 18. We can use either of those equations for Q, right? 16P minus 8 or 16 minus 2P. Neither of those look very good, right? For using my fraction, I'm looking for something that might cancel my 18 out. It's not looking so good. So I'll just pick the first one. Q is 16P minus 8. So Q is 16 times 24 over 18 minus 8. 16 times 24 is 384 over 18 minus 8, and I have to get that 8 over 18. And so what I do is I just multiply it by 18 over 18. So what I get here is 8 times 18. So I get 384 over 18 minus 8 times 18 is 144, bless you, over 18. Now I can combine these fractions. So 384 minus 144 is 240 over 18. And I'm just going to leave it at that. Okay. So we've got P is 24 over 18 and Q is 240 over 18. Therefore, the equilibrium is when P is 24 over 18 and Q is 240 over 18. Oh. Don't forget to do both because it's worth 2 marks or maybe even 4 marks each, right? But the P is worth half and the Q is worth half. So when you only give me one of them, I get so sad. So just remember to give me both. Any questions about that one? So like I promised, I'll post the solutions to these shorter answer ones, but that one was a quick kind of short answer one, so we'll stop there. But 6 through 11, I'll post those solutions. But otherwise, if you have any questions, let me know. Say that again. Yeah. Yeah. So I'll give you all the answers. Yeah. No, I'll bring a formula sheet for you. So don't worry about that. Just bring your calculators, yeah? All right. No more questions? It's on Tuesday. Here, you get the entire class. Bless you. I will see you then.
Is there any more like practice?